Imagine you're standing in a sunlit park on a normal afternoon. Suddenly, without warning, the sun blinks out of existence. To understand the immediate consequences, we have to look at what just vanished. The sun is a massive fusion reactor, converting 600 million tons of hydrogen into helium every single second. That nuclear reaction releases an incomprehensible amount of energy. Earth intercepts only a tiny fraction of that output, about 175 quadrillion watts. Yet if that reactor were deleted right now, nobody on Earth would notice. Because of the vast distance this energy must travel, we would go about our day in total ignorance for exactly 8 minutes and 20 seconds. That delay exists because the universe has a strict speed limit. Light travels at 186,000 miles per second. To cross the 93 million mile vacuum of space between the sun and the Earth, a photon needs a little over 8 minutes. Light isn't the only thing bound by this limit. The sun's gravitational pull also propagates through the solar system at the exact same speed. At the 8-minute and 20-second mark, the final photon reaches the surface. The sky turns pitch black. At that same instant, the gravitational tether holding our planet in place snaps. Every physical sensation we experience from the sun is a transmission from the past. Our planet has just run out of echoes. In his theory of general relativity, Albert Einstein showed that orbits are not created by a magnetic-like pull. Instead, planets travel in straight lines through spacetime that has been curved by the immense mass of a star. When the sun disappears, the local spacetime flattens out entirely, instantly removing the curve that Earth was following. Without that curved space, our planet defaults to Newton's first law of motion. Objects in motion stay in motion in a straight line. Earth would break its circular path and hurtle straight forward into the void at roughly 67,000 miles per hour. We would become a rogue planet, unattached to any star system. The sun's gravity was the only physical architecture keeping our world from wandering aimlessly into the lethal cold of the interstellar void. Adrift in the dark, Earth faces an immediate thermal crisis. Our climate is driven by the energy budget, a precise balance between the solar radiation coming in and the terrestrial radiation going out. With incoming shortwave radiation abruptly dropping to zero, this atmospheric budget enters an extreme deficit. Heat dissipation in the vacuum of space happens through thermal radiation. Without the sun, our planet's retained warmth begins to rapidly bleed out into the dark. Within a single week, global surface temperatures would drop to roughly 0 degrees Fahrenheit. Earth's atmosphere offers no real insulation. Without a continuous external heat source, its warmth is instantly surrendered to the void. The loss of heat is devastating, but the cessation of light is more immediate. The moment the sky goes dark, all global photosynthesis stops. This map shows global primary production in the oceans. This process is the mathematical engine of the global food web, driven entirely by solar irradiance hitting the ocean surface. This data shows the absorption spectrum of different phytoplankton. They rely on absorbing precise wavelengths of sunlight to survive. When those wavelengths drop to zero, the phytoplankton die. As the foundation of the marine food chain, the entire ocean ecosystem collapses with them. As the food web starves, the drastically dropping surface temperatures cause the oceans to begin freezing from the top down. Biological life is a temporary chemical reaction, catalyzed entirely by incoming solar radiation. Several months later, Earth is a frozen crust sitting under a brilliant, star-filled sky, now completely devoid of any atmospheric light interference. While humanity might attempt to survive in deep underground bunkers, Earth's core generates only geothermal heat. Supporting millions of people through this internal source would involve an impossible logistical scale. Internal heat can keep rock molten deep beneath our feet, but it is insufficient to sustain complex biological food webs or human agriculture. Returning to reality, we see Earth back in its orbit within the galactic habitable zone. Our placement here is incredibly delicate. Periodic changes in Earth's orbit and tilt, known as Milankovitch cycles, show that even microscopic shifts in our angle to the sun trigger massive climate disruptions, like past ice ages. Human ingenuity has historically relied on leveraging this precise positioning. These ancient structures at Mesa Verde were built into rock overhangs to capture low winter solar angles for warmth, while blocking the intense summer sun. The sun functions as a master engine, continuously injecting the exact amount of energy required to keep our fragile world from returning to the void.